Hello and welcome to Chapter 16 in Advanced Programming, specifically linked lists and pointers. Now, what you have to understand in reference to linked lists and pointers, everything you've done so far has been at a baby walk. When Chapter 16 is concerned, linked lists and pointers, everything from here on out will use pointers. Period. From here on out, everything is required to use pointers. So this is the part that basically separates, okay, can I do the rest of the items? Can I not do the rest of the items? So it's very, very important. And when you take a look at the 4 items that are assigned for this particular chapter, they build on one another. So the very first one, I believe, is a basic linked list. The second one is a linked list where you're searching by 2 elements. The third one, I think, is saving it to a file and editing and things along those lines. But what's really important is you have to understand linked lists. So what I've done is I pulled up the presentation, kind of talked through some things. So basically the idea is a pointer, when you declare variables, and this is all hidden, but what happens is that name of that particular variable points to where the data is contained in memory. It's a label that points to it. Now, where you're concerned, you don't care. I mean, it hasn't made any difference to you. But what we've done so far is we've created static data structures. So when we create an array, it's a static data structure, meaning that if we create an array 100 long, it's got 100 elements to it, I can't grow it, I can't really shrink it. In Visual Basic, they had the redim preserve where the arrays were concerned, and what that is that's pointer support that's hidden because that's a dynamic data structure. And it says here char state 3, this is actually a pointer to the array elements of state, and state is a pointer to those array elements, but it's hidden from the programmer. So it's actually a pointer that's actually hidden. And we're going to get kind of to these elements here a little bit more involved. And this is our dynamic versus our static. So our static, once again, when you declare it, it stays that way. Dynamic can change at runtime. And it's very dynamic dynamic data structures are very, very powerful. Now, the way it kind of works is when we create a head pointer, or the beginning of our particular item is, and let me pull up, let me pull something up here. Let me pull up Paint as an example to give us some to work with here. And we want to paint. Now, what goes on when we actually do our head pointer or things along those lines? A head pointer actually points to where our data is. So it'll actually say head, here's our head pointer. And the head pointer, when we reference it, is it's a memory address. Oh, poop. See how often I use Paint. It is a memory address, and it is actively used that when we call head, it tells us where the rest of the data is. And then each element from there is basically a series of nodes that end in a null at the very end. So here's each pointer points to the next one, right? So we've got, yeah, who knew, right? So let me delete that here. Let's make it easier. So this pointer will point to this one, and this particular pointer will point to this one. Now you have to remember, this is non-contiguous pieces of data. So in our particular case, it may look that conceptually they're all over the place, but realistically, they're all over the place, but conceptually, they're one right after the other. But these might be any memory location. And this can contain any amount of data. So if I have a node of a user-defined type or an object that I've created, then that could contain more than a particular one item. In our case, when we're dealing with our linked list concept, we have our head pointer that points to the county node. And in the county node, we have our name and we have our population, and then we have the address. So name, population, address, name, population, address, and then it ends at a null. Now, if we only had one element in this particular linked list, this address of the next node would point to null. Null is a way to figure out where at the end, and you have to kind of remember that as we go through. So let's figure this out in a very basic way. Struct chemical element creates a structure that contains element name and atomic weight. That's all it does. I haven't declared it, I haven't done anything with it. Okay, so now what I do is I do chemical element star my pointer. Now the star my pointer, it actually creates a dereferencing, says that my pointer will point to an element that contains element name and atomic weight. So it creates a spot in memory that will be used to place an address. It is important to note that it doesn't contain anything. It's preparing it. It's saying this particular item, when you have elements, will be pointing to it. Then my pointer equals new chemical element. This makes my pointer point to a new node of type chemical element. So here's our type chemical element. This assigns my pointer to that type of chemical element. Now what's important here, as of yet, chemical element doesn't have any data. I still have to put data in it. This is not a linked list. All this is a pointer. All this is a pointer to the actual element itself. I haven't done anything with it. So right here, for some reason it lost my node. I don't know why. Or not my node, but my pointer. So let's get back to this here. Lots of stuff. Okay. So if you see right here, it'll say my pointer equals new chemical element, right? So what it's doing, it's assigning it. It says if my pointer is not equal to null, meaning that if my pointer hasn't yet been signed, string copy my pointer element name nitrogen, meaning it's going to take nitrogen and it's going to put it in my pointer. And then where it says my pointer equals atomic weight, blah, 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 blah. What it's doing is it's assigning values to those particular elements. Now, what's important here, let me pause this here. I seem to be running into an issue with my, hold on. There. Hopefully that gives me my my pointer back. Does not give me a pointer back. Oh, crap. Sorry about the technical difficulties. I got it all back now. Okay, so what happens is this actually, all I've created is one node. My pointer, this one node. You'll notice this node doesn't have any links. It doesn't have anything that connects to it. It is totally all by itself. So my pointer points to element name and atomic weight. Then what will happen is I'll fill it. So I'm putting in nitrogen, 14 point, all of this, into this element. Then it says cout, element name, my pointer. Now it's important when it says my pointer, it's actually following my pointer, to element name, and then seeing it out. So my pointer is actually referenced, follows it along, and then sees it out. My pointer, atomic weight, sees it out. Then it deletes my pointer, meaning it gives it back to memory. Because what happens when it creates that node is it's creating a location in memory, and it reserves it. What I want to do is I want to give it back so the machine can actually use it again. Alright, so let's continue. Now, when a linked list is created, it usually involves a number of functions working together in order to perform the different tasks. So we've got the one where it actually creates the node itself. Hey, it has the element name and element number, and we put values in it. Boom, no big deal. But it's not considered a linked list because there's not a large number of nodes involved. There's only that one number of nodes. So in our particular case, we've got about 4 items. We've got add node. This usually takes in the values you want to add into a linked list and adds a node into the end of the list. Move current to end, there are a number of items where you need to move. Okay, display list and delete list. You cannot usually have a linked list without those elements. Alright, so I'm going to go ahead and stop this for my pointer keeps disappearing in presentation mode, so I'm going to just go with this. Okay, so the very first thing I do is I create a struct county node. And this is actually the main program where I'm dealing with a linked list. And a struct county node is contained county name, population, and county node at next, meaning that the next pointer is prepared to point to another node that has county node in it, right? So I declare county node head pointer and county node county pointer. So I've got 3 pointers here. There's nothing in them, but they can point to the elements necessary. Now what then happens is int get county data, This actually goes away. This calls int get data, right? And what get data does is it actually retrieves the information, and get data looks like this. Meaning that if it's false, right, gets a county name, enters a population, and then returns it to keep data. Now, you don't have to do it this way. This is just what they do. And then at the point in time it returns, which will be this line here, when it makes a call, right? Which is actually right here, sorry. These are actually our prototypes here. So I've got add node that takes in the name and a long population. We've got a move current to end, a display list, and a delete list. Those are the four main items that I need for a linked list: add, move, display, delete. So assuming that I've actually created and gotten data, so get county data, that's our get county data that I just showed, that got the name and the population. It then assigns the head pointer equal to the new county node. So what goes on here is I've got my head pointer, right? And here's my head pointer, and it points to my new county node, which is right here. As of yet, there's no data in it. So what happens is as I look at this, it is going to be a flat null is what it actually points to at the end. So here we go. So this actually points to a null. Now the reason my county data, this is my new county data and I put it here, is the head can't actually, the first time it goes through, I can't use it to loop through because head has to point to brand new data. Otherwise it simply won't work. So you'll note right here is it says head pointer equals new county data, string copy head pointer county name, head pointer is population, head pointer equals next. So what I'm doing is I'm setting up the very first element. Here's my head pointer. I copy in the data in here, right? So here's my data I copy in, and I do that on this line right here, string copy head pointer county name, head pointer population. Now, what I then do is, while they continue to keep the data, get county data, name, population. Once again, you can use any function that you want in order to get the data, but this is what's important. Then it calls what's known as add node. So let me go to add node. Now, the way add node works is it takes in a character name and a long population, meaning it takes in the name and the population. It says county node equals new record pointer. So I'm creating a county node that's a new record pointer. I haven't done anything with it. New record pointer equals new county node. So what I've done out here is I've created a new county node, So here's my new county node, and then here's my new county node, right? And here's my pointer to it. So here's my pointer to new county node. And then at the very end, my new county node just points to null. That's all it does. So this is pointing to null. Now over here, I still have the actual linked list. This is the actual linked list. This is the new county node. So I have two different separate nodes, one list, the actual node. So kind of let's continue from here. This would not be continuing from there. So let's bring this up. Now, new record pointers, so it assigns values in population, it assigns value in name, and then it makes an x equal to null. Got it, we've done that. Move current to end. Now, the way move current to end says, move current to end. Current pointer equals head pointer. So it puts a current pointer and a head pointer both pointing to the same thing. So here's my current pointer. And current pointer and head pointer both point to the same thing because they're equal to one another. Right? So now this is kind of how it starts. And then it says, while current pointer at next is not equal to null. Well, current pointer at next is equal to null. So it's automatically stopping. Now normally what would happen is current pointer equals current pointer at next. So if I had more elements here, it would make the current pointer point to whatever the next one does, and then it would continue. So it would actually loop through the particular linked list one node at a time. But because it doesn't exist, we don't have that issue. Then what I'm going to do is I'm going to return back to my add node code, and it says current pointer at next equals new record pointer. So what happens is I come along here, and here's my current pointer at next. So current pointer at next equals new record pointer. So there's our new record pointer. And basically what happens is I access this particular next, and I make it point here. Oops. So now it's connected.